So in this video, we're learning how to factor trinomials when a is greater than 1, and we are looking specifically at quadratic trinomials, so where we have some variable squared. Like in number 1, we have a x squared, in number 2, we have a p squared. So remember that the general form for these trinomials is ax squared plus bx plus c. So we're doing problems where this a value is greater than 1. And if you guys haven't already done so, I would suggest watching our other video that is factoring trinomials when a is equal to 1, just to get an intro to factoring before we jump into these harder problems. So let's dive into number 1. So number 1 is 2x squared plus 11x plus 5. So what we want to do first is draw this x over here. And this is just to organize our work. So you don't really need it, but most students find it helpful to have this. So in the top of our x, we are going to multiply our a and our c value. So remember, this is our a value here, and this is going to be our c value based on this formula at the top of our screen. So if we multiply 2 by a positive 5, we get a positive 10. We're going to put that right up here. In the bottom, we're going to put our b value. And the b value is just the value that's next to the variable that's by itself. So positive 11 is the b value. We're going to put this down here. So we put a times c at the top, we put b on the bottom. And now we want to find two numbers that multiply to this, that add to our b value. So two numbers that multiply to a positive 10 and add to a positive 11. So those two numbers are going to be positive 10 and positive 1. It doesn't matter what order you put these in. And now what we're going to do is we're going to take our equation. We're going to keep this first term the same. We have 2x squared. And we're going to take this plus 11x and break it up into these two numbers we found, so into 10 and 1. So we're going to break it up into 10x and 1x. We're going to keep this plus 5 the same. And we're going to think about it. 10x plus 1x is equal to 11x, so our expression is still the same. So just to reiterate, we just broke up our middle term of 11x into two terms using these numbers as the coefficients, so 10x and 1x. And now what we're going to do is something that's called factoring by grouping. So what we want to do for factoring by grouping is factor the first two terms and then factor the second two terms separately. So remember, factoring is just pulling out what something has in common. So if we look at 2x squared plus 10x, they have a 2 in common and they have an x in common. So I'm going to pull that out. If I pull a 2x out from 2x squared, I'm just left with an x. If I pull a 2x out from 10x, I'm left with a 5. And you can mentally check this by redistributing. So 2x times x is 2x squared, 2x times 5 is 10x. I'm going to do the same thing for this plus 1x plus 5. So they don't really have anything in common, so we're just going to take out a 1. And we always want to take the sign of the first term in our pair. So we're going to take out a positive 1, and we're just left with x plus 5. And now what's really important is these should always be the same. If they are not, you made a mistake, or the equation is not factorable. So now what we're going to do is we're going to take the one that's the same, so we have x plus 5. That's going to be one of our parentheses. And then the other parentheses are going to be these numbers on the outside, the 2x and the plus 1. So we're going to have 2x plus 1. So we get x plus 5 times the quantity of 2x plus 1 as our answer. We're going to go through a bunch more examples to make sure that this makes sense to you guys. So let's go to number 2. So again, we're going to start by drawing our x. Up top, we're going to have a times c. So our a value is 4, and our c value is 4. So we get 16. And remember, this is a, and this is c. On the bottom, we're going to put our b value. This is our b value. So our b value is negative 17. So now we need two numbers that multiply to 16 that add to negative 17. So we know both of our numbers have to be negative because they have to multiply to a positive number but add to a negative number. So we're going to do negative 16 and negative 1 because those multiply to a positive 16, they add to a negative 17. And now what we're going to do is we need to split our middle term into two terms with these numbers as the coefficients. So we keep 4p squared the same. And then this negative 17p is going to turn into a negative 16p and negative 1p. We have plus 4. The order in which you put those p terms does not matter. You could put negative 1p first and then negative 16. Your final answer will end up the same. The other steps will look a little bit different, but it does not matter which order you do that in. So now we're going to factor by grouping. So we want to factor these first two terms and pull out what they have in common. So they have a 4 in common because 4 and 16 are both divisible by 4. And they have, and they have 1p in common. So we're going to take out a 4p. If we take out a 4p from 4p squared, we're just left with p. And if we take out a 4p from 16p, we are left with 4. Now we're going to factor these two. So the only thing they have in common is a 1, but remember, you always want to take the sign of the leftmost term in the two terms you're factoring. So we're going to take out a minus 1. If we take out a minus 1 from minus 1p, we're left with a p. If we take out a negative 1 from 4, think about it like we're dividing a positive 4 by a negative 1, we're left with a negative 4. So I'm going to say that again. We took a negative 1 out. Right? When we're factoring, we're just dividing each term by what we're factoring out. So if we divide positive 4 by negative 1, we get negative 4. And now these are the same, so we know that we're doing it correctly. And now the final step is you're going to take what's in the parentheses, that's the same, so the p minus 4. And then the second set of parentheses is going to be made up by those two terms on the outside. So this 4p and this minus 1. So we get the quantity of p minus 4 times the quantity of 4p minus 1. Let's go over some more examples. So we're going to take a look at examples 3 and 4, but first I'm just going to write this ax squared plus bx plus c in case we're forgetting what a, b, and c are. So we're going to start by drawing our x for number 3. Up top we're going to have a times c. Remember, this is our a value and this is our c value. So you have 5 times negative 12, which is negative 60. And down here we're going to have b, which is just going to be negative 11. So now we need two numbers that multiply to negative 60 that add to negative 11. So those numbers are going to be negative 15 and positive 4. So take a second and think about that. So negative 15 times 4 is negative 60, and negative 15 plus 4 is negative 11. Now what we're going to do is we're going to split this middle term up into two terms with these coefficients. So we're going to have 5k squared minus 15k plus 4k minus 12, and now we're going to factor by grouping. So we're going to factor these two terms first. So we can pull a 5 and a 15, or we can pull a 5 out of 5 and 15 because they're both divisible by 5. And we could take a k out of k squared and k. If we pull a 5k out of k squared, we're just left with a k. If we pull a 5k out of 15, we're left with a 3. Or I should say, if we pull a 5k out of a minus 15k, we're left with a negative 3. So we get 5k times k minus 3. And now we're going to factor these two. So negative 12 and 4 both have a 4 in common. Remember, we always take the sign of this leftmost term. So we're going to take out a plus 4. If we take a 4 out of 4k, we're left with k. If we take a positive 4 out of negative 12, or you think about it like dividing negative 12 by positive 4, we get negative 3. These are the same, which is what we want. And now the last step is to set up our two sets of parentheses. So we're going to take that set of parentheses that's the same. We have k minus 3. And then our second set is going to be made up of these two terms on the outside. So it's going to be 5k plus 4. And I haven't said this yet, but the order of this does not matter. So this could also be written as 5k plus 4, times k minus 3, because when we're multiplying, the order does not matter. So we get either of these two as our answer. Let's take a look at number 4. So number 4 is 2n squared plus 3n minus 9. So we're going to start with our x. We're going to multiply a by c. Our a value is 2. Our c value is negative 9. 2 times negative 9 is negative 18. And our b value is a positive 3, so that's going to go down here. Now we need two things that multiply to negative 18 that add to 3. So take a second and think about that. You could pause the video if you want. So we're going to do a positive 6 and a negative 3, because positive 6 times negative 3 is negative 18, and positive 6 plus negative 3 is positive 3. And now we want to go into splitting our middle term up into two terms with these numbers as coefficients. So we have 2n squared plus 6n minus 3n minus 9, and now we need to factor by grouping. So we can take a 2n out of 2n squared plus 6n, and if we do that, when we divide 2n squared by 2n, we're left with n, and when we divide a positive 6n by 2n, we're left with a positive 3. And now for negative 3n minus 9, we could take out a negative 3. Remember, take the sign of that leftmost term. If we divide negative 3n by negative 3, we're just left with a positive n. And if we divide negative 9 by negative 3, we are left with a positive 3. These are the same. So we are doing it correctly. So now we set up our parentheses. One of them is this n plus 3. And the other one is made up by these two terms on the outside. So 2n minus 3. And remember, you can switch the order. So we get the quantity of n plus 3 times the quantity of 2n minus 3 as our answer. Let's go through two more just to make sure it's really clicked. So I'm going to start by writing ax squared plus bx plus c at the top. And for these two problems, I encourage you guys to pause the video and try to work through them on your own. And then you can unpause it and watch me go through the problems to make sure you've done them correctly. So number 5 says 5b squared minus 13b plus 6. So we want to start by drawing our x. And in the top of our x, we want to put a times c. In this problem, our a is 5 and our c is 6. So when we multiply 5 by 6, we get a positive 30. And in the bottom of our x, we want to put our b term, which in this problem is negative 13. So we're going to put negative 13 down here. And now we need two numbers that multiply to positive 30 that add to negative 13. And if you take a second and think about it, we should get negative 10 and negative 3, because negative 10 times negative 3 is positive 30, and negative 10 plus negative 3 is negative 13. So now what we want to do is split our middle term of negative 13b into two terms with negative 10 and negative 3 as coefficients. So we're going to have 5b squared minus 10b minus 3b plus 6. And now we want to factor the first two terms. So we can take out a 5b from 5b squared and negative 10b. If we divide 5b squared by 5b, we're left with a b. If we divide negative 10b by a 5b, we're left with negative 2. And now we want to do the same thing for negative 3b and positive 6. So we can take a negative 3 out from both terms. Remember, you always want to take the sign of the leftmost term. If we divide negative 3b by negative 3, we're just left with a positive b. And if we divide positive 6 by negative 3, we're going to be left with a negative 2. These two sets of parentheses are the same, which is what we want to see. And now finally, to make our final answer, we're going to take the parentheses that are the same, so b minus 2. That's going to be our first set of parentheses. And in our second set of parentheses, what we want to do is take these two terms here. So the 5b and the negative 3, and we're going to put those together, just add them together. So 5b minus 3 in our second set of parentheses. So we get b minus 2 times 5b minus 3 as our final answer. And moving on to our last problem, we have 6x squared plus 11x minus 35. So again, let's start by drawing our x. In the top, we're going to put a times c. So our a term is 6, and our c term is negative 35. And if you guys multiply those together, you should get negative 210. And in the bottom, we want to put our b term, which in this problem is positive 11. So I'm going to put a positive 11 here. And now we need two numbers that multiply to negative 210 that add to positive 11. And if you take a second and think about that, we should get positive 21 and negative 10. So now what we want to do is split our middle term of negative 11x into two terms with 21 and negative 10 as the coefficients. So we're going to have 6x squared, we're going to have plus 21x minus 10x minus 35, and now we are going to factor the first two terms separately and the second two terms separately. So if we want to factor 6x squared plus 21x, we have to think what goes into both of them. So we can take out a 3x from 6x squared and 21x. If we divide 6x squared by 3x, we're going to get 2x. If we divide 21x by 3x, we get a positive 7. You want to do the same thing with negative 10x and negative 35. And remember, you want to take the sign of the leftmost terms. We're going to take out a negative number. And negative 5 goes into both of those terms. If we divide negative 10x by negative 5, we get a positive 2x. If we divide negative 35 by negative 5, we get a positive 7. These two sets of parentheses are the same, which is good. And now we're going to write our final answer. So our first set of parentheses is going to be the 2x plus 7. And in our second set of parentheses, we are going to put together these two terms that are on the outside of our parentheses. So we're going to have 3x minus 5. So we get 2x plus 7 times 3x minus 5 as our final answer. So hopefully this video helped you guys learn how to factor trinomials when a is greater than 1. If you need some more practice, check out the link in our description for a free worksheet containing extra practice problems similar to the ones we worked through today.